Hello and welcome back. So this is the MacTempTosh version 2, which is a mini Macintosh 128K lookalike temperature meter that displays the current room temperature by using the ADT7420 Based seed groove module. Its previous version featured a similar setup, but the temperature sensor was different. So I swapped out the temperature sensor and made few minor changes to the body and made version 2. This video is gonna be about how easy it is to use the ADT7420 sensor and how to prepare a simple temperature meter with it. Also do check out this project's page for more detail. So without wasting any more time, let's get started. The heart of this project is the ADT7420 sensor, which is a high accuracy digital temperature sensor that is well used in industries. It comes in 4mm by 4mm LFCP package and it contains an internal band gap reference, a temperature sensor and a 16-bit ADC to monitor and digitalize the temperature to 0.0078 degrees Celsius resolution. The ideal operating voltage is between 2.7 volt to 5.5 volt, but it is better to use this module at 3.3 volt or use an LDO in between the power source and the sensor. Read its datasheet for more brief detail. By using the ATD7420 IC, I designed a sensor module that was based on the seed groove module series. This module was made by following the ATD7420 minimal schematic that was in the datasheet. I first prepared a schematic for this module and then converted it into a board file. After finalizing the file, I sent the Gerber data to Seed Fusion for PCB assembly along with bill of material file and the assembly instruction. I received the board in a week, which was super fast. We first set up the basic breadboard setup for testing the ATD7420, and for that I am using this Arduino Nano board with an OLED screen to display the temperature measured by the groove module. We connect the SCL and SDA of both groove module and the SSD1306 OLED with A4 and A5 pin of the Arduino Nano. Next we connect the VCC and the groove module to the 3.3 volt as the ATD7420 is a 3.3 volt tolerant device and a voltage greater than 3.3 volt will fry the IC. We connect the VCC of the display to 5 volt of the Arduino Nano. Next we connect the ground of temperature sensor and the OLED to the ground of Arduino Nano. The setup is now ready to be programmed. Here's the sketch that I've used in this project. Both the display and the temperature sensor are I2C devices. So they share the same SCL and SDA pin, but their address is different. This sketch gets the temperature from the ATD7420 sensor and display it on the OLED screen. The temperature readings are refreshed after 1 second. As you can see, this setup works and we have current room temperature, which is supposed to be accurate. For checking the accuracy, I compared the readings from the ATD7420 sensor with my previously made thermometer, which is based on the DS18B20 temperature sensor. The ATD is showing 28.57 degrees Celsius and the DS18B20 is showing the 28.19 degrees Celsius. There is a difference of 0.38 degrees Celsius, which is precise enough. The actual room temperature according to my thermostat is 28.5 degrees Celsius, so the ATD is much more accurate. As for the 3D body, the previous MacTempTosh had sensor fitted on the front panel, but this one holds the sensor module on the left side. There's a window for exposing the sensor to air so the sensor could take readings without any obstruction in its path. This model consists of 3 main parts, which are the main body, the front cover and the front lid. After editing the model, I 3D printed all the parts with my Ender 3 using a 1 mm nozzle with 0.32 mm layer height with 20% infill, with support only for the front lid. Parts are not of pristine quality. 1 mm nozzle cut down the time significantly, so all these parts were made in less than an hour, which is totally crazy fast. As for the internals, ESP32 is being powered as before with the IP5303 module that provides 5V to the ESP32 for power. Seed groove module is connected with the ESP32 through the I2C pin along with the OLED screen in parallel. Both share the same pins but have different I2C addresses. VCC of both display and sensor is connected to the 3.3V and ground is connected to the ground of ESP32. We start the main assembly process by first adding the IP5303 boost module on the front lid by using the hot glue. Next we add the switch on the front lid as well by following the same hot glue method. After this, we place the SSD1306 display on the front cover part and secure it in its place by using hot glue. Next, we place the ADT7420 sensor on the left side of the base body. We make sure to place sensor in the middle of the slot on the body. Hot glue is being used here as well to hold down the sensor in its place. Now we place the lithium ion cell in its place. Next we add the front lid on the bottom side and then cram the ESP32 inside the main body. We then close the front cover and then secure all the parts by using 6 M2 screws. MacTempTosh is now completed. Here's the result, a working temperature sensor that displays the current room temperature. The meter senses temperature via the opening in the left side of the body that exposes the sensor IC package. It can then sense the air around it and read the temperature data. This meter can even made smaller and compact by using a minimal Atmega 32AU or ESP3212F setup to run the OLED and the sensor instead of using a full development board cram inside. Version 3 will tackle this space aspect of this project. Until then, stay tuned for the next project. Special thanks to Seed Studio for providing help for this project. Do check them out for getting all sort of electronic module and microcontrollers kit. They even have PCB manufacturing and PCB assembly services. Do check them out. Peace out and I will see you next time. Bye bye.